Introduction to tail regrowth. Lizards are remarkable creatures with a unique ability to regrow their tails after losing them. This fascinating trait is not just a quirk of nature but an evolutionary adaptation that enhances their survival. The ability to regenerate a tail involves a complex biological process with significant advantages. The mechanism of tail regrowth. When a lizard loses its tail, a process known as autotomy occurs. The lizard has specialized muscles and tissues in the tail that allow it to detach at a specific point when threatened. This mechanism is controlled by a reflex, enabling the lizard to escape predators while the tail continues to wiggle and distract the threat. Regeneration process. After the tail is shed, the lizard begins the regeneration process. Cells at the site of the loss rapidly start dividing to form a new structure called the blastema. This mass of cells will eventually differentiate into the various tissues needed for a new tail. Over time, the tail regrows, although it may differ in appearance from the original, often lacking complex structures like the original tail's vertebrae. Purpose of tail regrowth. The primary benefit of tail regrowth is survival. The ability to drop and later regrow a tail helps lizards escape from predators. The detached tail acts as a decoy, allowing the lizard to flee while the tail continues to wriggle, distracting the predator and providing the lizard with a crucial escape opportunity. Regrowth efficiency and limitations. While lizards can regrow their tails, the new tail is not always identical to the original. The regenerated tail may lack the original complexity, such as the spinal vertebrae, and is often composed of cartilage rather than bone. Despite this, the new tail can still serve its function in balance and signaling. Energy and resource allocation. Regrowing a tail requires significant energy and resources. During the regeneration phase, the lizard may experience increased metabolic demands and a temporary reduction in its overall health and activity levels. The process can be taxing, especially if the lizard loses its tail multiple times in a short period. Evolutionary advantage. Tail regeneration provides a significant evolutionary advantage by increasing a lizard's chances of survival after a predator attack. The ability to regrow a tail enhances the lizard's ability to escape danger, ensuring that it can continue to reproduce and pass on its genes. Behavior and tail loss. Lizards often exhibit behaviors that minimize tail loss. For example, they may display warning signals or engage in defensive postures to avoid being captured. Tail loss is generally a last resort when other escape strategies fail. This behavior underscores the importance of the tail in both predatory avoidance and survival strategies. Conclusion. Lizards' ability to regrow their tails is a remarkable example of evolutionary adaptation. By sacrificing and regenerating their tails, lizards enhance their chances of survival in the face of predators. This process, while energetically costly and resulting in a less complex new tail, plays a crucial role in their overall fitness and ability to thrive in their environments.